So this video is going to help you read the periodic table and enable you to be able to do the proper calculations to find number of electrons, neutrons, protons, and dealing with atomic mass numbers. Alright, so just a couple things about the general periodic table before we start. All the elements that we know of are organized into the periodic table, and the periodic table can tell us a ton of different information about them. It's actually pretty incredible. So just some basics to start off with. The rows that we have over here, so the rows going from left to right, we call these periods, hence the name the periodic table. Whereas the columns, so from top to bottom, all through the periodic table, we call these groups, and the groups are what we where we find our chemical families. Okay, so we'll talk a little bit more about those in class, where we see some similar behaviors between the elements that are in the same group. Alright, so let's look at an actual element from the periodic table, and this is the same format that you guys have on your periodic tables that I've given you in class. So I'll just kind of go through the different components of this. So first off, we'll start with the easy ones. So this here, the big letter, okay, this is the element symbol. Okay, this down here is the element name. Okay, usually the symbol and the name, usually the symbol is the first letter or two of the name, but that is not always the case. Some of the symbols are based on the original Latin names, so you'll see a little bit of a discrepancy there. Now the numbers, there's always two numbers in each kind of square on the periodic table. The first one is up here. This is the atomic number. The atomic number. So the atomic number gives us the number of protons in the nucleus of this element. Okay, so the atomic number gives us the number of protons in the nucleus, and it also gives us the number of electrons that are in a neutral version of that atom. Okay, because number of protons and number of electrons are always going to be the same in the atom form. Okay. Now this other number here, this is what we call the atomic mass. Atomic mass or atomic mass number. Okay, the atomic mass is the average mass of the atoms of that element. Okay, so what this takes into account is not only the number of protons, the number of neutrons as well that are in the atom. Alright, and before we move on with talking about the periodic table, I just need to do some reminders about the atom. Before the break, so we have our three subatomic particles in the atom, the proton, the electron, and the neutron. The proton and the neutron are in the nucleus. Okay. The electron is orbiting around the nucleus. Okay. Now, if you guys look at this table up here, which you guys have in your notes, I want you to look at the charge and the mass. Okay, so the proton and the electron are the subatomic particles that have charges. Okay, the proton is positively charged, the electron is negatively charged. Okay. An atom in its elemental form will have an equal number of protons and electrons. It will be balanced, so it will be neutral. Okay, so the protons and the electrons will equal each other. Remember also that the mass of an atom is mainly in the nucleus. Okay, so we have the protons with a mass of 1, neutrons with a mass of 1, electrons have a mass that is so small we consider it 0 in this case. Okay, so the mass is all coming from the nucleus, from those protons and from those neutrons. So with that said, the fact that the mass of an atom comes from the protons and the neutrons that are in the nucleus. Okay, let's talk about those numbers that you see on the periodic table again. So a couple of formulas that you're going to need to understand in order to kind of go with this. So the number of protons plus the number of neutrons is going to be our atomic mass. Okay, so the mass of a certain atom is going to be entirely due to the number of the protons and the number of the neutrons that are in that nucleus. Okay. Next, if you have the atomic mass number and you subtract the atomic number, you can get the number of neutrons. Okay. Why is this? Remember that the atomic number and the number of protons are the same. Okay, so these are equal. All right, so as I've said, this is our atomic number. Okay, our atomic number is also our number of protons. Okay, it'll also be in a neutral atom, the number of electrons as well, but we're not really concerned about the electrons at this point in time for these calculations. Okay, so that value is right here with number of protons. Okay, it's also the atomic number. Okay, so we can put that number into those formulas. Okay, now the other one is the atomic mass number. Okay, so as we talked before, this number down here is the atomic mass number. Okay, you will notice that it's not a whole number, and it rarely is on the periodic table. It usually has some decimal places, and the reason for that is that there's not the same number of neutrons in every single atom of, say, carbon. Okay, some have most have 6 neutrons. Every once in a while you find one with 7, which means that some atoms of carbon have a different mass than other atoms of carbon. So for the periodic table, they actually take the average of that, so they look at how common each atom is with those numbers of neutrons. They take the average of it, which is why we don't have a whole number on the periodic table. But for these calculations that I'm going to ask you to do, and I'm going to ask you to find the number of neutrons, what you're actually going to use is not the number from the periodic table. You're actually going to use a number that I give you. So let's try a really simple example problem using these formulas, which are not too complicated, and hopefully you agree. So this would be an example of a problem. Nitrogen has an atomic number of 7, which we see on the periodic table, and an atomic mass of 14, and that's a rounded version of the atomic mass that we see on the periodic table. We're always going to use the atomic mass. It'll always be given to you. Okay, so then the question is, how many neutrons does it have? Okay, so we have the atomic mass number, we have the atomic number, we want to know the number of neutrons. Okay, so I'm going to take the atomic mass number, which is always going to be the bigger number, 14. I'm going to subtract the atomic number. Okay, the answer is 7 neutrons. All right, let's try another one. So this question is a little bit more complicated. So if an atom of beryllium has 5 neutrons, what is its atomic mass? Okay, so we are supposed to find the atomic mass number. So that's our unknown. If an atom of beryllium, it has 5 neutrons, so we know this. Number of protons is the same as our atomic number, and we can look on the periodic table to get that. Okay, so once you look on the periodic table and you find beryllium, beryllium has the symbol Be, and it has an atomic number of 4. Okay, so we have that. We can get that from the periodic table. So we add 4, the number of protons, add it to 5, the number of neutrons, and we get 9. Okay, so the atomic mass is 9. All right, I'll do one more example problem. So this one is an atom of chlorine has a mass of 36. How many neutrons and protons does it have? So let's start with protons because it's the easiest, right? The number of protons is just going to be the atomic number that we can read on the periodic table. So you have to find chlorine on the periodic table. And when you find it, you will see that it has a 17 in the upper left corner, which is the atomic number, so it has 17 protons. Okay, so now we know this, and we know the atomic mass number. Okay, so we're trying to find the number of neutrons. So we're going to use this formula over here. We know the atomic mass number, we know the atomic number, we're going to find the number of neutrons. Okay, so the atomic mass number is 36. Okay, I am subtracting the atomic number. And so the overall number of neutrons, the answer is going to be 19. So the number of neutrons is going to be 19. All right, so I'm just going to finish with questions in this form, which is the form that you'll be practicing them in class, which is just kind of filling in the blanks in a large table. Okay, I want to remind you that this atomic mass here, you don't use the number on the periodic table. Okay, so not from the periodic table. PT. Okay, you are going to be either given an atomic mass or you're going to have to find it based on the neutrons that you've been given. Okay, so let's start with this first example. Lithium. It's given us the number of protons it wants us to, it's given us the number of neutrons it wants us to find protons, electrons, and atomic mass. We'll start with protons because that's always the easiest because it is just the atomic number. And I need to look at my periodic table for that. So this one, we are going to use our periodic table. Okay, so when I find lithium on the periodic table, I find the atomic number is 3, which is the number of protons. Okay, in a neutral atom of lithium, there's going to be the same amount of electrons and the same amount of protons. In this case, the neutrons is the same amount as well. So the atomic mass is going to be protons plus neutrons. So 3 plus 3 is going to be 6. Okay, let's do this next one. So they haven't given us the atomic symbol for this next one. We have to find it. This is an atom with an atomic number of 6. I know that it has an atomic number of 6 because it has 6 protons. So I look on the periodic table. The element with the atomic number of 6 is going to be carbon. So I put C there for carbon. Okay, so the atomic number is 6. The number of electrons is going to be the same. It's going to be 6 as well. Now all I have to do is find the neutrons. In order to find the number of neutrons, I need to take the atomic mass number. I need to subtract the atomic number. So 13 subtract 6 is going to give us 7. And that's it. When you're doing these problems, you'll want your periodic table handy and also these formulas handy, either from your notes or written on the top of the page. Good luck!